A single machine here can haul 450 tons, the weight of an entire blue whale pod, in one load, powered by diesel and electricity fused into mechanical muscle. Yet these monsters remain almost invisible, moving mountains to shape our world. How did such unimaginable giants escape our attention, and what secrets do they reveal about the true cost of modern civilization? At ground level, the scale becomes almost impossible to process. A single tire stands over 4 meters tall, higher than most living room ceilings, each one engineered to carry more than 100 tons. The BelAZ 75710, a titan among mining trucks, stretches nearly 15 meters from front grille to tailgate and towers 10 meters above the pit floor. Its ladder rises like a fire escape, climbing up the side of a steel building. Operators ascend step by step, disappearing into a cab perched stories above the ground, where a single seat overlooks a dashboard of digital gauges and heavy-duty controls. The heart of this machine is not just its size, but its power system. 2 diesel engines, each rated at 2,300 horsepower, turn massive alternators. Electricity flows from these generators to 4 traction motors, one for each rear wheel set. Instead of relying on traditional gearboxes, the diesel-electric drivetrain delivers torque directly through thick cables and copper windings, allowing the truck to climb steep, winding haul roads with a full load. This design eliminates the need for complex multi-speed transmissions, reducing mechanical stress and making each ascent smoother, even under the strain of 450 metric tons of ore. Every movement is choreographed. Dispatchers monitor screens in remote control rooms, plotting the route for every truck, loader, and support vehicle. Operators guide these giants along ribbons of gravel carved into the mountainside, maneuvering switchbacks and blind corners with the help of GPS and radio commands. Each run is a high-stakes ballet. One miscalculation could put millions of dollars in equipment and ore at risk. Inside the cab, the operator's silhouette is framed by panoramic glass. Hands rest lightly on the controls, eyes scanning digital readouts and the distant horizon. Outside, heat shimmers above the exhaust stacks. Steel vibrates with the pulse of engines and electric motors. When the truck rolls forward, the ground trembles. This is the hidden choreography behind the raw movement of mountains, a dance of mass, power, and precision that keeps the arteries of modern civilization flowing. The Komatsu D575A stands idle for a moment, its blade stretching 7.4 meters wide, almost as long as a city bus. When the engine roars to life, the ground vibrates under its 1,150 horsepower. Each pass of the blade shoves aside up to 69 cubic meters of earth, enough to fill a backyard swimming pool in a single surge. Tracks as tall as a grown man grind forward, crushing rock and clay with a weight that tops 150 metric tons. The dozer's steel fortress moves with purpose. Carving shoulder roads and reshaping the pit floor, its blade hydraulics flexing as they adjust tilt, angle, and lift in real time. Inside the cab, the operator feels every push through the seat and the controls, making constant micro-adjustments to keep the blade steady, the load balanced, the progress relentless. But brute force is only half the story. Nearby, the Liebherr R 9800 hydraulic excavator rises like a building, its boom arching skyward. The bucket, sometimes configured to hold as much as 42 cubic meters, dwarfs the pickup trucks parked at the edge of the site. Yet for all its size, the excavator moves with a surprising grace. Each movement is guided by a set of joysticks so sensitive that a 0.2-degree nudge shifts the bucket arc by just 5 centimeters. The operator's hands rest lightly on the controls, fingers making minute corrections as the machine's high-pressure hydraulic lines respond instantly, flexing and coiling with each command. Load sensing systems inside the excavator adjust oil flow on demand, matching power to resistance, conserving energy, and keeping heat in check. The difference between these two giants is more than size or muscle. The dozer's blade is a declaration of power, pushing walls of earth in slow, unstoppable waves. The excavator, by contrast, is an extension of the operator's intent, each scoop, curl, and swing mapped precisely from hand to steel. In the span of a few decades, the evolution from mechanical muscle to hydraulic finesse has transformed mining, turning raw force into a dance of precision, where the outcome depends as much on operator skill as on the weight of the machine. A lattice boom rises at the pit's edge, cables alive with current. The P&H 4100 XPC electric rope shovel draws over 13,000 kilowatts, more than a dozen locomotives combined. High-voltage cables snake across gravel, tying the shovel to the mine's substation. Unlike the diesel haulers nearby, this machine never idles for fuel. It runs on grid-fed electricity, its motors governed by variable frequency drives that convert digital commands into smooth, tireless motion. The operator, high in a glass cab, guides the dipper as steel teeth bite into fractured rock. Each bucket holds over 20 cubic meters, enough to fill a haul truck in just a few passes. Sensors track every cycle, and a technician checks the substation's readouts, making sure voltage stays steady. The grid powers not just the shovel, but the conveyors and lights that keep the mine alive, every machine pulsing to the same current. This efficiency wasn't always possible. Early rope shovels ran on DC motors with carbon brushes, sparking and wearing down in dust and heat. Crews worked through the night, swapping out parts, fighting friction. The shift to AC induction motors and digital drives changed the game. Now, sealed bearings last for years, and operators adjust bucket speed with a joystick. The result, a machine that moves hundreds of thousands of tons daily, with less downtime and up to 40% less energy use per ton than hydraulic rivals. The 4100 XPC's 1,500 kilowatt draw and 158 cubic meter bucket mark a leap in both power and precision. But the quest for scale started decades ago. Archival footage shows Big Muskie, a dragline whose bucket could swallow a car 168 cubic meters in one pass. Fed by direct AC, it drew nearly 18,000 horsepower, dimming lights in nearby towns. Its walking pads, as wide as city streets, inched the giant forward. Today's rope shovels are smaller, but their digital control and grid-fed power set a new standard, shifting focus from brute force to efficiency and control. Beneath the city, the tunnel boring machine moves with a quiet certainty. Its cutter head, 17.45 meters wide, rotates against the earth, carving a path with unbroken focus. The engineer stands close, eyes on pressure gauges and digital screens, attuned to the faintest change in sound. Every few meters, the machine halts. A robotic arm swings forward, lifting a concrete segment and pressing it into place. Laser sensors check the fit, holding the tunnel's path within 5 millimeters of the plan. Each ring locks in with a hydraulic hiss, sealing darkness behind and leaving a flawless circle. Spoil drops onto a conveyor, carried away along a steel artery that stretches the length of the machine. Crews check the ring erector, refill grout, and watch the stream of material flow toward the surface. The process repeats, ring by ring, a rhythm of advance and assemble, building a tunnel beneath rivers and streets. Above ground, the bucket wheel excavator stands nearly 97 meters tall, its frame stretching longer than a city block. The wheel turns, buckets biting into lignite, feeding a conveyor system that runs the entire length, 200 meters of belts in motion, moving earth in a steady flow. Inside the elevated control room, the operator sits surrounded by screens. Sensors track every rotation, every load, every shift in alignment, guided by GPS and laser theodolites. The operator's hands rest on the controls, making fine adjustments as the machine crawls forward, meters at a time. Fluorescent lights flicker in the corridors. Maintenance crews move along catwalks above the endless motion. Unlike shovels and trucks, the bucket wheel excavator is a mobile factory, its operation continuous, its appetite constant. Day and night it carves the landscape, conveyors forming highways of steel across the horizon. Millions of cubic meters of earth move through its system, every action monitored, every parameter logged. Here, precision and mass merge, and the line between machine and infrastructure blurs. Perpetual motion is engineered, sustained by hands both seen and unseen. Tonight, hundreds of machines, some taller than apartment buildings, move Earth while cities sleep. As global demand for raw materials surges, these giants keep growing, shaping landscapes and futures alike. The scale of industry is no longer out of sight. Its true impact is right beneath our feet. What will we build next?